Let's look at the key attributes of our exponential functions. And you can see this is what an exponential graph looks like. So I don't have this in words, it's just a piece that's kind of curved but not exactly like our quadratic. So our domain is going to be the same. It's our x values scan from left to right. So let's scan left to right. At the leftmost point, we've got us going on for infinity. And at the rightmost point, we go on for infinity that other way. So my domain is all real numbers. My range, always going to be my y values when we scan from bottom to top. So the unique thing about my exponential functions is we can see it's defined on here, but there's a point in which this exponential function starts flattening out, and then we have this line which we'll mention in a second. But what happens at this line is it's not ever going to touch that line, and it's not going to cross that line, and it's just going to get super close to it. So for my range is always going to be a y is greater than or y is less than some number. If it's not, so that number that it's going to be less than or greater to than is going to be this line right here. So this line we can see it's on the x-axis, so that's y equals 0, and everything is above there, so it's greater than. We don't use that equal than sign underneath because it's never going to touch that line, so it's never going to be 0. Alright, x-intercept is the point where it crosses the x-axis. Again, we would write these as that crossing point, comma 0. And for our exponentials, we could have none. None is okay. So let's look. Here's our x-axis, and remember I said that that gray outline right here, it will define it in just a moment, is at 0, x equals 0, so it's actually never going to cross the x-axis at all. So there is no x-intercept here. Alright, let's look at our y-intercept. That's where it's crossing the y-axis. Again, we might not even ever cross the y. None is okay. We've got the y-axis. Oh, it does actually cross here, so this is my y-intercept. And that is at 0, 3. Alright, this line right here. This grayed out line right here. It's very important. It's called an asymptote. It's a horizontal asymptote because it's a horizontal line. And this is the flattening point of the parabola. So this one we're going to be writing as a y equals a number line. So you can see how my exponential is flattening out right there. That's why it's our asymptote. And that's at y equals 0. One other thing to point out is we can tell if it is increasing or decreasing. And we always start left to right and follow your finger. Starting at the left to the right, I go up. If I go up, it's increasing. So this is increasing. If I had started here and my graph instead went down like that, then it would be decreasing.